Hi, friends. Welcome again to another episode of Beyond the Clouds Edge to Edge Transformation. And as we have talked about earlier, this transformation is happening at every level. Individually, we see the difference every single day, the kind of things we're using, the technology is changing very rapidly, and even in the workplace. And here with me today is a good old friend, Richard Paw. Richard and I worked together in a synthesis company, which was the older generation of AI, Synopsys, and that's also getting transformed to new tools. Richard, tell us about your life, your story. How did you become the Richard Paw I know today?
Shankar, thanks for having me here. I'm happy to join such a great and illustrious set of interviewees. After I graduated from UC Berkeley with my double E degree, I started at a company called Actel. From there, I evolved to doing some digital design. I did work in tools and methodology. I wound up also working with the Mil-Aero community. I wound up on the team that helped develop the Actel's first space part. I was there for probably about 10 years. After that, at Synopsys, I focused on helping the company and its products align around what's coming down the pipe from infrastructure vendors, operating systems around microprocessors, looking at which technologies are coming down and how to adapt to them. Things at that point in time, things like multi-core, issues like storage, partners like NetApp, being among the first to look at infrastructure as something that matters. After about 11 years at Synopsys, I moved on to work for a storage company, EMC, which was bought by Dell. It was about that time while working with customers in semiconductor, talking to friends in the large companies. They were having trouble keeping up with the infrastructure demands for advanced nodes. And at that point in time, advanced node was 7 nanometers. This was probably around 2017 time. That got me thinking that maybe it's time to start to revisit the cloud. The large companies were struggling, then the small companies would have no chance of touching those nodes in terms of infrastructure. The industry did look at the cloud back in 2011. At that point in time, the large companies were able to still keep up with the growth, and which we see is every process node, there's probably been 20 to 40% increase in compute demand. And they kept up with that. Around 2016 was where they're struggling. That's why I started looking at how to move the industry up into the cloud. Joined a startup, Rescale, at that point in time that had a business already working with high performance computing and moving those workloads up into the cloud. I joined them to help with semiconductor. After Rescale, I moved on to AWS, Amazon, and then finally over here at Microsoft. And here at Microsoft, I'm focused on working with the semiconductor industry, the partners in there, which includes EDA vendors, foundries, working to make sure that Microsoft has the tools and infrastructure required to service chip design and looking at how to incorporate new technologies, generative AI being a new one, into the design process. At the end of the day, all we're doing is looking at how to increase productivity of engineers and how to address the needs as we move forward. If you look at the demands of future chip design projects, they're only growing while the number of people are not. We have industry that is not getting enough new blood. So we need to do more with fewer people.
Very true. And people like you have moved on from core semiconductors into enabling semiconductors. And I'm glad we need a lot more support to make the semiconductor vision come true. And given the cell economy, the rate at which silicon is moving forward and which is necessary to make AI happen, how can large cloud providers like Microsoft help change the dynamics to make it easier for people to use the cloud and the edge?
We're looking at things like what are the barriers for companies to get onto the cloud? For small companies, their barriers center around security. They don't have IT folks that are cloud literate to be able to build an environment to go there. So we're looking at how to make that easier, how to create a vehicle that companies with zero cloud experience, because if you look at most folks in semiconductor, we know Linux pretty well. Everybody is familiar with Linux. We cut our teeth on that. Where the gap is networking, security. How do I build firewalls? How do I build a safe place to do chip design? Helping with that is one major thing, and their efforts around there. We've worked with ISVs to help them build their own cloud environments, Synopsys and Cadence being good examples of that. We are looking at coming out with solutions that help with that as well. That's for the small and medium folks, but also looking forward to the larger ones, how they can more easily collaborate with each other. Almost every single chip design company, even the large ones, often use a contractor, how they can leverage that, or working with debug with their vendors. The cloud is a good place to do that kind of work because it becomes a neutral territory where you can collaboratively work with your vendor or your contractor, assign additional resources. Those are the type of flexibility you need. For the large customers, they're looking at dynamically bringing on resources as needed. The good thing is for the large companies, a lot of them have already moved to the cloud in other spaces. So they need less help in terms of cloud and more help in terms of methodology. That's where you want to come in and help them understand, given their chip design flows, where you can fit in, how you can help augment that. And that's where the large companies have struggled.
And you've seen this whole change towards generative AI. I think the biggest change in semiconductor design was when Synopsys started synthesis. And a lot of changes have been fairly incremental. Gen AI looks like something big. Ansys announced that they're being acquired by Synopsys and the partnerships with the cloud providers. What are your expectations? Is this an incremental step or is this going to be a step jump?
I think it's going to be both. You're going to see both an incremental step and large leaps, and it's going to be different in different areas. If you look at how Gen AI is going to fit into chip design, there are multiple places. There's areas where it affects how you code, things like test bench generation, things like how you understand what you need to do. Generative AI is a good way to consolidate your documentation and get what you need out of that more effectively. You're going to see generative AI being used to help generate scripts to help you get your work done. So that would be an incremental thing where helping to generate code would be more of a revolutionary thing. You've got Copilot coming out of Synopsys, creates a tool expert that you can ask. That is a large step function, but a lot of this stuff is in line with what has happened in industry. If you look at going from synthesis from schematic capture, that was a jump. APR from hand layout, depending who you are, you can look at that as either incremental or a big jump. These things happen over time. And as we do them, we're going to get better at it. Right now, what we're seeing is most folks for code generation are saying, show me how to do an adder or something like that. It'll give you sample code. You're looking at the code, and then you take that as inspiration to write your own. That's how we see a lot of folks doing code generation today. As the system learns and as more confidence is built, you're probably going to see more modules auto-generated. But today, we see it mostly used as inspiration. Right? We're still early days.
I know
It's
it's
like
the Wild West again.
it is.
And
So
speaking of the Wild West in software, looks like there's a Wild West going on in hardware as well. There was a time when Actel and all were young companies, and the whole FPGA revolution made it possible for many more people to make chips. Today, there's so many players coming in, whether it's smaller ones like the Samanova, the Cerebras, and others trying to make AI chips. And then there are these entrenched players, cloud players like Microsoft, Google, and Amazon. Do you think the whole hardware software landscape is shifting in some ways?
I think folks are looking at optimization, how to get the most out of what they can do. And folks are realizing that software runs on hardware at the end of the day. And software optimization, they're doing that already, but where can they get more mileage? And that's where hardware comes in. That's where you're seeing a lot of folks doing silicon design right now. Automation is making it more possible for more folks to start doing it. There was a time not too long ago, folks were saying silicon startups are a thing of the past. It's impossible. Now we see such a huge influx of startups. We have organizations like Silicon Catalyst helping companies get started. Ecosystem has developed to a point where that is possible. As far as the non-traditional silicon companies, they're starting to see advantages on where they can get the last 10% of horsepower, cost savings out of doing their own stuff, making their own chips. That's driving it.
And looks like we are now entering the era of software driven hardware. We are already
Mhm.
seeing vehicles that are software driven and maybe even factories that are going that way. What do you think is happening in the silicon area? The promise that FPGAs had of software being used to change the way hardware works, and now it's happening real time. Is it realistic to see more and more software driven hardware platforms going forward?
Again, it's kind of an evolution. You see the pendulum swing from software to hardware over time, multiple times in their history. You see a lot of focus on hardware for a little while, then shift to software to get more functionality out of what hardware is there. After a while, you get to a point where folks develop the software to a point where they need changes in hardware to make that to go to the next step, and the pendulum swings back. What you're going to see is that pendulum swing more quickly moving forward, like everything else. And that's a good thing. That's how innovation happens. It does mean that the industry is going to have to adapt more quickly to these swings. It's not something that we haven't done before, to be honest.
The idea of low code, no code has been around in software for quite some time. A lot more things are happening at a much higher level. Is it possible in the near future we'll start to see low code, no code hardware design as well, with lots of IP, lots of
Mhm.
resources available?
It's been creeping to that in its own way. If you look at the modern SoC, most of what the modern SoC is are IP. There is some in-house development, but a lot of it's optimization. It doesn't make sense to develop stuff for yourself because the to integrate into a modern system, there is such a large ecosystem that you need to carry with you. Everything is standard PCI, USB, the code base for a processor. Unless you have an ecosystem for all of those things, you're not going to tie in to the larger world. Low code is almost there now for chip design because so much of it is bought externally. You're not buying the IP just for the implementation, but for the ecosystem that comes with it, including the verification infrastructure. It's impossible to verify much of this stuff without the verification ecosystem that comes with it too. So we're almost there.
That's true. In fact, we used to honor people who use verification IP by
Mhm,
calling it the VIP cafe. That was a dream 10 years ago.
mhm,
Today, you can't think of designing without having design blocks, IP blocks,
mhm.
including verification blocks. You have worked as a hardware designer, you've been a software developer, now you're doing infrastructure, cloud, you've done storage. Which part of the journey did you enjoy the most, or what aspect of it did you find the most interesting?
All of it has different parts that are interesting. The part that was the most core was probably the chip design, the logic design part of it. That was an early part of my career. It was where a lot of stuff grew out of. Just sitting there solving the problems of how to get things done. There's a certain amount of satisfaction that you get from figuring out how to implement your ideas in silicon.
I miss those days when we would literally handcraft chips. Now it's so automated. It's
Mhm,
like running a piece of software now. The way
mhm.
we think about hardware has changed dramatically.
That's a
Yeah,
good thing. We want to get to a point where traditional software folks can come in and create chips. There's more software folks than hardware folks. If you're going to have innovation and new silicon moving forward, we need to be able to pull some of those folks in, make it accessible for them to be able to take what they know of coding and create silicon out of it. So I think that's going to be where we need to look to the future, being able to increase our numbers by making it more accessible.
that's true. It is necessary to democratize the process of making chips now.
Exactly.
Otherwise, we
Yeah.
won't find enough engineers.
Yeah.
One of the interesting things that has shifted, I remember the days when I was working on the Pentium, we literally had to go to the office to do anything.
Mhm.
And especially if you're dealing with a wafer or a chip, you had to be in the SMART and all the things. Today, so much is virtualized with digital
Mhm.
twins and doing things remote. So, one of the interesting things that has happened is that you can work from anywhere, anytime.
Mhm.
But that puts the burden of balancing your life on the individual. Now that you're working on the cloud and you're actually advocating the cloud, how do you make sure that you have a work life balance and the people in your team have a work life balance?
That comes with discipline and experience, knowing when to let work intrude on life and when not to, and just making sure that your lifestyle is one that you can achieve that balance. The team that we're on is good. The manager looks after that balance and respects boundaries. You have to respect folks' boundaries so that when they need to get things done, they can. Most of us live in a world where at the end of the day, what you get done, how much you get done is what really matters. How much time you spend in an office is not that relevant because not all the time in the office is productive. You want that productive time. So sometimes is it useful to spend an hour or two in traffic? No, you're better off spending that time doing work. But there is still some value in the face-to-face meetings, and understanding how that balance works is important. In meetings like Teams meetings, Zoom meetings, they tend to be very regimented. What you have on the agenda, that's what you talk about. In face-to-face, it's much more free-flowing, and you go off on tangents because you're just sitting there and chatting. Those tangents are sometimes quite valuable, but that happens less in a remote situation. That's kind of the balance you need to understand how to get a good balance of both.
Very true, very true. There was a time when there were mainframes and minis and workstations, so everything was like the big iron. And
Mhm.
then we went off into PCs. The Microsoft Intel combo democratized hardware. People were able to work for the first time from homes and from remote places. And now we're going back to the cloud. But again, there's this movement towards the edge. Where do you think this cloud edge movement is going to settle down? Are you seeing more and more interest in private clouds, hybrid clouds, multi clouds?
To be honest, I don't think it is going to settle down. Right? It's going to continue to evolve. There are certain things that big clouds are good for. If you need a lot of horsepower, that's what you're looking for. But edge is good for low latency. Where you need something right away, immediacy, that's where your edge resources come in. So it depends on what you're doing. If you need fast response, you're probably going to do something on the edge. If you need a lot of resources, the core cloud data centers are basically where that's going to happen. It's almost going to be a continuum of needs, and depending on what you're doing, it's going to be different. Chip design is one where it's very centralized in terms of what we do, but as you get global teams going, you're going to start seeing things like if 90% of chip design is non-transactional, you create your designs, it's mostly a text base, and you're queuing up jobs to run. That can be done from anywhere, so those large central systems work well. Now, if you're doing things that are more like analog design or physical layout, where you're interacting with a graphical representation, you're going to need things much closer to where you are physically just because of the speed of light and latency. That's where you're going to see, again, a mixture of edge type resources and cloud type resources. You're going to see a combination of all of it. Every job has a different need.
And as you clearly pointed out, the complexities of these projects, many of them are going global. And
Mhm.
there are always these pockets of expertise. For example, manufacturing with EUV is very much now in Asia,
Mhm.
slowly trickling back to the US. And we've got design expertise, particularly in AI, neural networks, which is very
Mhm.
much US Eurocentric, and you've got test expertise in different parts of the world. In terms of learning, getting this through AI to have to go to the next level of automation, we can't just be doing it on the cloud. So, is there some kind of a federated learning process that's evolving where regional expertise can be integrated to make it possible for everybody to be more competent?
I think actually AI is going to be one of those things that helps with that because one of the things that we see is that if you look at chip design, typically you have a few expert gurus in an organization. They know the ins and out of tools, they know the ins and outs of the way design is done at the company. If you can use AI to help create models that can help with that type of question. Good example is a junior engineer would come and say, I need to do this. How do we do this here? And they'll walk you through based on what we do here, the coding styles in this company. This is how we do it. Based on the methodology we employ here, this is how we do it. If you can type into an AI system that same question, I need to get this done. How do I do it? And it can put that out and feed that to the junior engineers. That's a good way to help train them. It also makes it so that if you have a distributed workforce, that one guy that knows how to do things doesn't have to be all over. Typically, that's somebody who's sitting either here or in India or in mainland China. Now, a junior engineer anywhere in the world can ask that question and get that feedback on how to get it done. So that's one of the things that AI can help with is democratizing that knowledge and making it so that that expert is global.
Since you and I both at different stages worked with military aerospace customers, and with the recent thing that we saw with Boeing, clearly there's a need for better engines, better aerospace, better technology in general. Do you think that the military aerospace industry could benefit from the newer technologies that are coming up with deep learning AI based systems? Or do you think the regulations will hamper that?
I think the government is starting to understand that they need to embrace newer technologies to keep up. We've seen moves like that from Department of Defense already. Their ramp program that Microsoft was involved with is one very good example of that, where they wanted to figure out how to allow their contractors, their suppliers, to develop chips in a secure way, knowing that they need to get to more advanced nodes, knowing that their suppliers have not kept up with the modern way of doing things, largely because of the restrictions they have. ramp program was one where they wanted to be able to facilitate prototyping. One thing that we enabled was the ability for them to do that work on the cloud. That allowed these companies to get more compute resources they normally would. It allowed them to work with their EDA vendors in a secure environment. It allowed them to ramp up and more quickly get to prototypes where they can target certain foundries like Intel and Global Foundries, certain US-based foundries, to be able to hit more advanced nodes, to be able to fulfill the needs of US military. And I think moving forward, we're going to see more of that, more focus on how to integrate more industry standard and more advanced techniques into their design flow.
I believe during the pandemic, for the first time, everybody felt the pinch when we could not buy decent cars. The supply chain was pretty damaged. And thereabout started the whole CHIPS Act. And
Mhm.
not only in the United States, but now we see it in EU, we see it in the UK, in India. Literally globally, there's some efforts to have local Silicon Islands, if you will, or at least some kind of supply chain that is more local. Do you think that's realistic? How far do you think the supply chain will get stronger with the CHIPS Act? And what can we do as hardware or software people to make it happen?
What the pandemic made clear to people was how important silicon is. Before that, silicon was taken for granted. No one gave it a second thought. It was just there. And then, like many things that are taken for granted, when they're not there, everybody realized how important it is. And that's what one of the positives that came out of that whole event, an awareness of the need for governments to focus more on building up semiconductor. Prior to that, I know there were several efforts by several people in industry to get the government to invest in semiconductor, which all fell on deaf ears. The government kind of figured that's a West Coast California thing. Why does the Midwest care? Right now, they understand that this is something that all nations need to care about. That focus is good. Also, prior to the pandemic, the market forces made it so that everything was focused on just purely efficiency and cost, which made it so that everything was just barely there, and we had very thin supply lines for everything because it's more efficient that way. It's cheaper that way. With the shortages that happened and the vulnerability to supply chain that were revealed, it made everybody realize that we need some resiliency in the supply chain. That's a good thing. What's going to happen is you're going to have second sources for these things, second sources from multiple geographies. The truth is, semiconductor is a global industry. It will remain a global industry because packaging is done in a different place where the raw silicon is sourced, which is a different place where your photoresist is sourced from, which is a different place where your lithography machines are sourced from. It is happening all over the planet. It will continue to be so because different areas have different expertises and different resources. As the industry grew, what you saw was multiple pockets competing. What happened was very quickly, as the market evolved and solidified, the competition fell away because the second source was lost. What happened was that we went to single source because they were the winners. But that also left it so that if anything happened to them, industry had a hole. What you're likely to see is the second sources coming back, where you have a backup for the different parts of the supply chain. That's the difference we're going to see.
It's interesting how the pendulum swings back and forth. And
Hmm.
hopefully, it's a dynamic equilibrium we are trying to create, which reminds me of people who are getting into the industry, a lot of anxiety, whether it's in software and definitely in semiconductors. What if what they're learning today will be outdated in a few months or a few years? What advice do you give people who want to either join the semiconductor industry or the software industry and have to deal with these changing things? How should they approach it?
The important thing to realize is whatever you learn coming in will be obsolete. I mean, simple as that. But what isn't obsolete is a mindset, the way of doing things. For software folks, if you look at code, we've gone from basic to Pascal to C to Python, Perl, Ruby. These things have changed. Java was big for a while. Like everybody learned Java. The language you learn doesn't matter. Same thing with chip design. What you learn today is a stepping stone uh, of what you're going to be doing. So the techniques are important. The mindset is important. Always be ready to learn more. Neither of us are doing what we thought we were going to do when we came out of school. Most of the folks in this industry are in that same spot. We're at the leading edge of technology that evolves so quickly that you really can't predict what you're going to do, but you can arm yourself with the right skills, the right knowledge, and most importantly, probably the right mentality going into this kind of career. Just realize you will be learning, you'll be doing different things in different parts of your career, but that's the fun part of it. You don't want to be stuck doing the same thing forever.
I can see somebody out there listening saying, dang, all I had to do was prompt engineering. That's what I thought. I have to do just co-pilots and I'm set for life. So you
Yeah,
think that'll continue to change? Which
it
reminds
will
me,
all change because prompt engineering a year ago was not a thing.
and it may not be, there'll be something else.
Yep.
Education is becoming interesting. During the pandemic, almost the world came to a standstill. If it wasn't for Zoom and Teams and
Mhm.
the whole cloud and edge infrastructure, there would have been no education for a while. Now we've got deep learning, we've got all kinds of co-pilots, right? In what ways can these be used to enhance education, whether it's in semiconductors or in any industry? I can see potentially tremendous progress that can be done. I can also see people getting more complacent. So, how can education be enhanced?
We need to educate the educators on how AI works and why it works and how to use it. The problem is that, like any powerful tool, it can be abused. Think of it as a calculator. When we were in school, we weren't allowed to use calculators because you have to do the math tables yourself by hand. Nowadays, my kid in class uses a calculator. They're being taught higher level functions. Once you get the basics, there's no reason to focus on them. You just move on and use it as a tool. AI is going to be the same thing. You learn the basics of reading and writing. You learn the basics of how to do things, and then the generative AI becomes a tool, or the AI in general becomes a tool. We have to treat it the same way. We need to make sure the kids learn the basics and then teach them how to use it as a tool. When you go to do your job later on, it's a tool you're going to have to use. So it'll be important to teach them that. Teaching the educators how to teach towards that is going to be the challenge. All of us have had to learn where to use a calculator and where not to, right? Right? And it's the same thing.
I still remember the first time I met you. You were one of the first people who talked about the cloud at Synopsys and why and how these dynamic resources will change the world. And today I see that happening. You've been at it forever. In those days, you're gung ho. Even today, I see the same thing in you. Early morning, late night, you've been at it forever. What is the thing that keeps you excited? What are the emerging trends that you have been following?
What excites me is how we can help the chip industry innovate and keep up with the demand of the future. So if you look at EDA tools, it's all about engineers do more with fewer resources. Same thing with cloud. That was again helping the scaling, getting more done with the same number of people. AI, again, more of the same, helping the same number of people achieve more, automate more of that function to be able to meet those needs. Helping the industry be able to do that is what excites me. We know that semiconductors can be the heart of the future. All of the advances in medicine, in aeronautics, in material science, those are all going to be facilitated by more compute, more silicon. Silicon drives all that. We're going to have the supersonic jets that everyone's designing are modeled in silicon. That's what excites me, being able to help to part of that process, part of that innovation to help the basis of the future happen. That's why I got into cloud. That's why I got into tools. That's why I'm looking at Gen AI. What's next? We'll know when it gets here. If I could tell you that, then we would both be rich.
Yeah, it's exciting to again be here with you, Richard. You've always been an amazing mentor, a coach to thousands of engineers. May you keep it up. And to people listening out here, yes, there are no simple solutions. Prompt engineering is not the ultimate. There will be co-pilots, different approaches to do things. So it actually helps to stay in touch. So if you see something that excites you, if you see something that challenges you, if you see warning bells, please come and talk to us. We really need to co create this future. We can't just be sitting on the sidelines and waiting for God to give us the best tools. That's not going to happen. So let's find a way in which we can cooperate and co create a harmonious future. Richard, again, it's a joy talking to you. It's always fun to learn new things, even on a call like this. So please keep it up. May you continue to support many more engineers and be like the quarterback or the coach behind the scenes in many cases.
Thank you for having me. It's always great talking to you.